last one.
94 or 34?
34.
34? Okay. All right, stick on about 30 seconds. Get as far as you can. Well, the square only tells you that it's a parabola.
Oh,
Okay, so which one are you looking at? 33? So it's got to be a parabola.
32.
So that the square won't affect us.
Oh, imagine with these.
Yes. Okay, does that make more sense now? Okay, yeah, there's two answers on the back. Yeah, you weren't here when I went. All right, let's take a look at what you got for these 23. Tony, what do you got for that one? E. All right, I'll agree with that. Negative x plus 1. So you got E, which, where is E at? B, C, D. All right, there it is. So it opens down, absolute value. How about 24, Jordan? C is correct. So you want C for that one. Matthew, 25. All right, 25 is a little bit goofy, but what do you got, Matthew?
I said G.
G is correct. It looks like an absolute value because what happens with x? You're taking the square root of x squared. Well, what's the square root of x squared? Just x. But you got to take into account the negatives. When you plug in a negative and you square it, it comes back positive. Okay, so it'll just be like a linear. You'll just see what it is there on G. You get that linear piece as well for that one. All right, Mackenzie, how about 26?
I didn't get that one.
You didn't get that one? All right, what type of graph is it? Absolute, well, it has to look like a what? V. It has to look like a V. What's the 1/2 do? What do you think?
Is it compressive? Horizontally?
Compresses it, not horizontally, but vertically. If it's outside, the constant's outside, and it's not with the x, it's vertical. So it compresses it. Justin, what'd you get for that one, 26?
H.
H is correct. So if you go down there to H, and it's really hard to see a compression and stretch when it's just like an absolute value. It's not as obvious as like if it was a circle or something on those lines. So you just kind of got to look at points. So 27. Hayden, what do you got for that one?
I got
I is correct for 27. Marissa, how about 28?
A.
A is correct. Katie, how about 29?
I had B.
B, good. Lizzie, how about 30?
I didn't get that far yet.
Not that far yet. All right, 30. Carter, how about 30?
I didn't get that far either.
Uh-oh, who's got 30? How about we go there? Matthew?
K.
Okay. All right, now let me just go through the other ones. 31 should be L. 32 is F. 33 is D. 34 is J. What? And now everybody, even if you haven't got to, turn to the next page. Look at 94. Let's just do. I want everybody to at least do that one at this point. Okay, look at number 94. They give you the description. You have to come up with the equation. All right. See what you come up with for 94. And that'll be just one page over, 278. You got the absolute value of x shifted 2 units right. Okay. Reflected about the y-axis. Stretched horizontally by a factor of 2. And then shifted 3 units down. Okay, so for all those conditions, okay, here's what you need to have. There's your equation. Shifted 2 units right. That's the -2 on the inside. Okay. What was the next thing they asked for? Reflected about the y-axis. The y-axis is where you change the sign of the x. So it has to be inside the absolute value. It has to be with the x. Well, if there's a constant there, you'll obviously make it the negative 1/2. Stretch horizontally. Remember, horizontal is kind of like reverse. When you stretch it, you use a fraction. When you compress it, you use a whole number. So it's going to be negative 1/2 x, and then shifted 3 units down as the -3. Okay. Take another minute or so. Look through here. And I will tell you, do need to know, given a graph like this, how to transform it. Like, so, if you're given a graph, what I mean by graph like that, where you don't have an equation, you can't substitute in. You're going to have to know, like, how to, when it has -2x, or when it has x plus 2, or where the negatives are, how it reflects it. So doing these bottom ones, you need to be able to come up with those. If you're struggling with them, or if they're just not quite sure, come in and see me. We can go through them again. Okay, sometimes I'll tell you, and we'll hit them a little bit here as we move forward. If you take a look over here, we got to do section 2.8 and 2.9. I originally thought we might be able to get it in Friday. That's not realistic. I want to make sure we're prepared. 2.8's like a day and a half. We'll start 2.9. It'll give us time to review. There's a lot of material on this test, so under the circumstances, what I'm going to do is there's a little multiple choice format on this test. I think there's 10 to 12 problems. We'll do that on Monday, and then we'll do it the second half of the period. So we'll have, like, I don't know, the first 15, 20 minutes or 15 minutes to go over a little bit of the review. You'll take the multiple choice part, and then the second part will be Tuesday. I'm not sure if it'll be more than 100 points. I got to just reevaluate it again. Typically it's 100 points, but if we're going to go, and then typically I only do it in one day. So there might add a couple things then. PSAT sign up, juniors, that's a really good thing to look to sign up for. That's where they talk, national merit scholars are determined for the PSAT. That's a really high honor. For if you're a junior and you get that, and then if you do get it, you end up getting all kind of mail from different colleges. Sometimes it can be advantageous. Sometimes it's just a nice little award to put on your resume. Okay, for that. But if you're, pretty serious about your academics, that's something that you should sign up for as a junior. Okay. Questions here? All right, let's take a look at those guided notes I handed out. We're going to be in 2.8 here. We'll get through most of them, but not all of them. Hopefully I get you a little bit of time to work on the homework. Basic operations of functions. You want to add, subtract, multiply, divide, and then the next thing is composite functions, or composition of functions, which you're not as familiar with. And then domain is going to be a huge thing throughout the whole chapter. Okay, we keep throwing that in for you. Okay, that's over there on your right. Nothing fancy. If you just see f plus g, it means you're adding the two functions together. F minus g, you're subtracting. Then you got multiplication. And then you also got division. Okay, for that. All right, let f of x equal 3x minus 4. I think we already got that on there. Then g of x equal 2x squared plus 5x. All right, you see f plus g. Now, I didn't leave you. If you write big, you're going to have to tone it down to fit everything in there. It's not like there's a ton to write, but I didn't leave you a ton of room. If you see this, it says evaluate f plus g. It's just saying add the two together, f of x plus g of x. So I'm going to take 3x minus 4 plus 2x squared plus 5x. It never hurts to put those two in parentheses. If there's a plus there, obviously it doesn't affect it. All you're doing is combining like terms. That is all you're doing, if there are any. Write it in descending order. It's going to be 2x squared plus 8x minus 4. Since there's no denominator, there's nothing that can cancel. You don't need to factor. You can just leave it like this. A lot of people say, well, there's a common 2, or they try to factor it. No, just leave it. Add them together, you're good. Part B, f minus g. F of x minus g of x. Well, for this, it is critical that you put that second one in parentheses because you're subtracting that whole function. So if there's more than one term, you've got to have it in parentheses. I'm just going to mentally distribute the negative, combine like terms. It's going to give me negative 2x squared. All right, I got negative 5x plus 3x. It gives me minus 2x. And then I got my minus 4. Again, you would have a GCF. You don't need to factor it out. Just leave that. That's f minus g. Okay? Third one, f times g. Well, no different here. F of x times g of x. Three x minus 4 times 2x squared plus 5x. All right, go ahead and FOIL combine like terms.
Oh, shit.
You make that one.
Yeah.
So what do I get here? I get 6x cubed plus 15x squared minus 8x squared minus 20x. I got 6x cubed plus 7x squared minus 20x. All right, and lastly, f divided by g, 3x minus 4, 2x squared plus 5x. All right, so you put, obviously you just start like that. This is one where you, since you do have a division problem, you can potentially cancel. I would look to factor. The only thing you can factor is to pull out an x in the denominator. So you get 3x minus 4 over x times 2x plus 5. So nothing cancels. It didn't really lead to anything, but it's simplified a little bit. Leave it like that. All right, what's your domain for D? Just take a look at it. Not that you need to write it down, but I want you to think through this. What is your domain for D? Matthew, or you can start with what can't it equal?
Can't equal 0.
Can't equal 0. Anything else?
Can't equal negative 2.5.
Negative 2.5. We'll call that negative 5 halves. Anything else? Say no.
No.
Good. Some people, you still get this 3x minus 4 doesn't affect it because it's in the numerator. That is allowed to equal 0. It cannot equal 0 in the denominator. So we get negative infinity to, the first one we come to is negative 5 halves. Union, negative 5 halves is 0. All right, take a look. The other three, what's the domain for the other three? Okay, what's the domain? Adam, do you know?
Negative infinity to infinity.
It is negative infinity to infinity. You can plug in anything, you'll get back an answer. You're not going to divide by 0 because there's no fraction, and you don't have a square root. So as long as you don't have either of those, it's automatically going to be all real numbers. So just sometimes you overthink that. That will be all real numbers. All right, take a look at this case here. You already have the functions down?
Yeah.
Okay. So, all right, what is f plus g? Okay, so that first one. So we want to find f plus g of 5. All right, well, all that means is f plus g of x is f of x plus g of x. This is going to be f of 5 plus g of 5. F of 5 plus g of 5. And so you're going to substitute it in individually, add those two together. So that's going to be f of 5 is going to be 5 squared minus 6 times 5 plus 8. That's your f of 5. Plus g of 5, 5 minus 2. What do I get here? I get 25 minus 30. Let's see, did I do that right? 5 squared. So 25 minus 30 looks like negative 5 plus 8, negative 3, plus 3. Okay, positive 3. So 25, negative 5 plus 8 is 3. 3 plus 3. All right, looks like I get 6. All right, so that's all you get. F of 5 plus G of 5, 6. Okay, for that one. All right, for B, what is F times G of negative 3? All right, go ahead and see what you get. F times G of negative 3. And it's just like we did on the other ones. It's going to be F of 3, negative 3, times G of negative 3. All right, substitute that in, see what you end up with. Anna Walsh, you get anything?
I'm almost there.
Almost there. All right, I'll just write down.
I just need to, it would be 35 multiplied by negative 5.
35 times negative 5?
I just can't do it.
Where's your calculator?
Still not with that.
Oh, okay. All right, 35 times negative 5. I think that's correct. So we got negative 3 squared. I believe it's minus 6 times negative 3 plus 5 times negative 3 minus 2. 9 plus 18 is 25. Oh, I missed something in there. Or did I? No. So 9 plus 18. Oh, 9 plus 18 is 20. What is that? 9 plus 18. 27?
It's
Plus 5?
plus 8.
Plus 8. Oh, well, I got 5 there. There we go. That's what I wonder what's going on. Plus 8. Hey, it doesn't want to. Or a 9. Let's see now if it'll work. There we go. Negative 3 minus 2. So we got 35 times negative 5. What'd you get for that, Anna?
Negative 175.
Good. Negative 175. Okay. So for that. So make sure you multiply those two numbers together at the end. All right. So for C, f of x equals x squared minus 6x plus 8. G of x equals x minus 2. Find f divided by g, state its domain. Well, do your first step. First step is just going to write f on top of g. Okay, you're just going to write it like that. X squared minus 6x plus 8 over x minus 2. But since it's a division, there's a possibility of canceling. What happens when you factor the numerator? Go ahead and factor that. It's going to factor into x minus 4 times x minus 2. What happens to those x minus 2? They cancel. Now, so you end up with f divided by g is equal to x minus 4. But you got to watch what we started with. What's its domain? Okay. The domain of x minus 4 is all real numbers. That will not be our domain here because we got to go back to the original. we got to go back to this case right here. What can't x equal right here? X can't equal 2. So we still have to throw that out. So our domain is negative infinity to 2, union 2 to infinity. Now, I want you to think about this graphically. All right, I got this in here. You can just pay attention here. All right, there's your f of x. There's your g of x. If you graph it, it's got to look like x minus 4. Okay, it's got to look like that. If I go to my table, it will say 2 error. It'll say an error. That's the only spot there's an error. Now, if I go to, you don't use this very often, but I know if I go to z decimal, if you look at it closely, you see where it missed that spot? There's a hole in the graph. Okay, so this is a case. It comes up rarely, but if you would graph it, so you're graphing x minus 4, it's going to hit at negative 4. At 2, it's usually at negative 2. There will be a hole there because it doesn't exist. Okay, so you just got to be careful. That's like one of those rare cases. All right, on the bottom there, you got a definition. Composition of functions. Okay, dealing with two functions. The composition function of f with function g is written as, it looks like far. Okay, do you remember seeing this from the past? All right, Matthew says yes. All right, you've seen this before. Here's a definition. It means you're taking f of g of x. It means you are plugging in just g of x function everywhere there's an x in the other function. Okay. You can also do it in different orders. So there's just kind of a outline of what's going on. X goes to g, g goes into f. That's going to be the same thing as the composition. You can also have g of f of x, and that's going to look like this. Okay, g of f of x. You can have f of x. You can make it look like that. That just means you're going to plug in the same function everywhere there's an x. You can have g of x. That's going to be the same idea. All right, flip it over on the back. All right, so you got those two functions, 3x minus 2 and 4x squared plus 5. All right, for part A, because you're going to see there's an A and a B here. All right, A, make sure you do both of those. Don't go down to where B is at this point. Okay, leave that room. So do those side by side. F of g of 2. Here's what this means. You can do it with a constant. So f of g of 2 it's going to look like that. What do we plug 2 into first? We plug it into the g function. Okay, evaluate g of 2. So I'm going to substitute that in. G of 2 equals, what's 4 times 2 squared plus 5? I get 21. Take that answer and plug it into where? F of x. We plug that into f of x. So f of 21 is going to be 3 times 21 minus 2, which is 61. So that means f of g of 2 is 61. All right, g of f of negative 5. G of f of negative 5 is also equivalent. It sounds exactly, I read it the same way. G of f of negative 5, so it looks like that. All right, plug it in. Don't do that. Don't do that one under B. Don't do that one under B. Do that to the right, because there's something different for B. Do that one to the right. Plug it in for F. Take that answer, plug it into G. See what you come up with. Now, f of negative 5 equals 3 times negative 5 minus 2. That's negative 15 minus 2 is negative 17. G of negative 17. 4 times negative 17 squared plus 5. Brooke, what'd you get? 1,161. 1161. I agree with. All right, so just double check that. 1161. All right, now you can do it for a specific point, or you can do it for a function. Same two functions. Okay, this is part B. You get two pieces of it. We're going to do f of g of x, and we're going to do g of f of x. Okay, and we're just going to simplify it. Okay, so we got f of g of x first. That means we're going to write it with the f on the outside, and the g of x is what we're substituting in. So 4x squared plus 5 will substitute in for the x, the whole thing. Okay, so just like you evaluate anything, except you're plugging in the entire function. So now, that's going to look like the following. So you get f of g of x. That's going to be 3. Take the x out, put in 4x squared plus 5. Don't forget the minus 2. And so I get 12x squared plus 15 minus 2. And so f of g of x equals 12x squared plus 13. Now g of f of x, it's not going to be the same. Okay, the g function goes on the outside, and we're going to substitute the entire f function in there. So that means f of x, this whole thing, 3x minus 2, goes in for that x. And so it's going to look like, let's see, 4, parentheses, 3x minus 2. That x is being squared, so you have to square whatever you plug into it, which means you're going to have to FOIL it. Okay, FOIL it. All right, go ahead and FOIL it and then distribute your 3. Or excuse me, your 4. And we get 4 times, what is that, 9x squared. All right, and when I'm done FOILing, I get minus 12x plus 4 plus 5. And then I get 36x squared minus 48x plus 16 plus 5. I got minus 48x plus 21. All right, let me just revisit the one above you just for half a second. We did f of g of 2, right? And we plugged it into g, we took the answer and plugged it into f. That would be the same as if we used this function here. Okay. So if I plugged in 2 into this, I get 2 squared is 4. 4 times 12 is 18. 48. And then 48 plus 13 is 61. So we got the same thing up above where we plugged it into G first and then we plugged it into F. Okay. If you're given this, you can go in this order, that's fine. If you're asked to do a bunch of them, you might want to do F of G of X and then substitute into there. But it'll always give you it'll give you the same answer. Okay, either way for that. All right, we'll finish the rest of that tomorrow, but I want you to do these here first.